We're now going to go forward to our last presentation of the day, a special video presentation from the University of Saskatchewan visiting professors. We would like to highlight and recognize our visiting professors, research scholarly works with the university community, and facilitate the opportunity to collaborate with their home university and other partners around the world. Thank you to visiting professors Dr. Qais Al-Efan from the Jordan University of Science and Technology, Dr. Jim Freer from the University of Bristol, Dr. Wenbin from the South China University of Technology, Dr. Yanggang Wang with the China Geological Survey, and Dr. Xuequi Zhang from the University of Victoria. Without further ado, let's play the video.
Hello, my name is Qais Al-Efan. I'm an associate professor at the College of Pharmacy, Jordan University of Science and Technology. My research focuses on adherence to medications among patients with chronic conditions. I'm engaged here with the College of Pharmacy and Nutrition, in particular with Professor David Blackburn, who is the lead of medication adherence research group at the College of Pharmacy and Nutrition. Our research projects address the third United Nations Sustainable and Development Goal, which talks about ensuring healthy lives and promoting the well-being of individuals at all ages. In our research projects, we focus on determining the problem of non-adherence among patients with chronic conditions, and we try to look at factors that are associated with the problem of non-adherence among these populations in order to think about and put strategies that will help in overcoming and solving this prevalent problem, and also to reduce morbidity and mortality associated with non-adherence among these types of patients. In one of our projects, which was published recently, we evaluated a pharmacist intervention in a First Nation community health center where the pharmacist helped the patients to enhance their adherence to their medications. And luckily, the intervention was successful, and we planned to expand the project to a larger scale and to include more communities, more First Nations communities. But because of the COVID-19 pandemic, our plan was suspended, and we shifted our efforts and worked to other research projects under the same focus, medication adherence. I'm really enjoying doing my research projects at the University of Saskatchewan. University of Saskatchewan provides me with a great environment, with a great research environment. University of Saskatchewan is a great university. I met great people in this university, and I'm really enjoying working here. And I would like to say thank you, University of Saskatchewan. Thank you, Professor Blackburn, for granting me this opportunity.
Good morning, everybody. My name's Jim Freer. I'm Professor of Hydrology. I recently retired from my position at University of Bristol, and then had a fantastic opportunity to come here as a visiting professorship position with the University of Saskatchewan, but based in Canmore under primarily Martyn Clark's group, but also working with other colleagues such as John Pomeroy, Paul Whitfield, etc., on primarily hydrological research. But my core focus for much of my career has been the development of hydrological models, process understanding, and in particular in what bonds all that together is understanding uncertainties within our predictive capabilities, and also the information that we use to evaluate these kind of models. But more generically, those techniques can be used to look at a variety of environmental modeling simulations And that's what I've done to a greater or lesser degree in terms of broadening what I've done in hydrology into other modelling on water quality, erosion modelling, climate change type studies, etc. So now I want to talk a little bit about what my goals are while I'm here in Canmore for 2 years, of which scarily 3/4 of a year has already gone under these interesting and strange COVID times that we're living in. Fantastic for me, the group is fundamentally looking at developing ensemble prediction systems for Canada and more widely North America, but things that are applicable globally eventually. And within that, there's obviously a lot of technical research to be done, both in terms of data sets available to test models, as well as developing the modelling systems themselves that can be applied across wide and varied environmental conditions. And the part of research which I've kicked off with also a research grant from Environment Canada is to look at the uncertainties and qualities of the discharge gauging systems across Canada. So that's been a kind of a first part of the research focus. So we're currently developing methods that can be applied to a national gauging river flow network and to evaluate the uncertainties within those gaugings at different flow levels and throughout the year, because there's fascinating changing environmental conditions that I'm not used to coming from the UK. For example, under ice gauging conditions that make this relationship that we use between the stage height of the river and the amount of water flowing through it change considerably. So there's some real challenges here, and we'll be hopefully one of the first groups to really develop a system that is applied per gauge and for most of the gauging network of Canada. Where this is really beneficial in that wider aim to improve ensemble forecasting and prediction methods across Canada in general is to improve the way that we then evaluate these model predictions for each of these river flow gauges by including the uncertainties within the gauge over time and for the different flow conditions. And this can significantly improve that relationship between the model predictions and the quality of the information that we have to evaluate those models, so that we don't overly constrain our model predictions when we know that perhaps some of the environmental information that we have at a certain place is has a significant uncertainty in its own right. This is fantastic then, because we can couple that with other research which is developing precipitation uncertainties. So we have an ensemble of inputs because we know our precipitation inputs to the model are not perfect. Then we have some parameter uncertainty and even model structural uncertainty within the models themselves. And then when we evaluate models, which is what I'm mainly interested in with the actual observations from the environment, then we can assess the uncertainties there. So that gives us a whole uncertainty prediction system to evaluate our models in, which will be a significant step forward compared to what's been done in the past, particularly for when you look at these more national or continental domain levels of modelling systems that the group is currently using. More widely in the group, we have a fantastic range of PhD students and postdocs who are engaged in various research strands, primarily a focus in environmental modelling and hydrological modelling in particular, from developing forecasting systems. So, for example, looking at future floods and droughts, and seasonal forecasting, to understanding what processes we need and developing processes, representations in models, and other core developments in how we even split up our environment and develop different parts of our modelling systems to improve our predictive capability. Within all of those, I am helpful where I can be, opportunistically, in terms of understanding some of the ways that we can develop those modelling systems from my own experience, and also understand the uncertainties in that predictive capability. So finally, I wanted to just reflect on what the pandemic has meant to my whole visit and these strange and unusual times we're in. Well, first to say, I felt nothing but incredibly welcome since I've been here, in terms of the support that I've had from the university, and also the way that Martyn Clark and John Pomeroy in particular have gone out their way to make the best of the way that we're working together. Obviously, in terms of my own research, it's primarily computer model simulation based, so I'm not been impacted by a lack of trying to deal with field programs and some of the more challenging aspects that a number of colleagues here have had to deal with. But of course, the disappointment is missing the social interaction, which you can't quite get through Zoom calls when you first come to a new group and meet research colleagues and start interacting over those all-important coffee breaks and talking about what all the fantastic students and PhDs, postdocs, etc. are doing. And I think that's been the challenge. We've done quite well as a group in terms of the way that we have coffees and communicate over Zoom, but it's still, I basically have an office down in Canmore that I've never sat in for a day so far after 3/4 of a year. And that's just a personal disappointment, really, in terms of the amount of interaction that we've had. But I would say for definite, everybody has done a brilliant job, nevertheless, of making me feel welcome and engaged within that group and the USask community. Hopefully, over this next year and a quarter, that will improve, and I certainly would like to visit Saskatoon and meet some of the other colleagues that I know there, for example, like Jeff McDonnell, who I've been working with on a paper while I've been here anyway. But yeah, it's just basically improving that day-to-day discussion and interaction and chatting about the research that we're all doing on a one-to-one basis that I'm missing, of course, as we all are, but in general the research is carrying on and it's not really impacted me in that way. It's just a little bit personally less rewarding in terms of meeting everybody and having that all-important human contact that we all obviously thrive on in terms of developing ideas and having those chance meetings and chance discussions to think about new things that you can work on. But yeah, that's it from me. And if anybody wants to obviously talk about any of the research areas which I am working on, I'm very contactable, of course, and very happy to engage with people if they're interested. And if you think you have some research which also I would be interested in within this community, then that would be fantastic also to know about, and please just get in contact and have a chat. And here's hoping to a better 2021 than probably what some people would have thought about 2020. But thanks very much for this opportunity, for giving you a quick overview of what I'm doing here, and appreciate it very much. Take care. Bye.
Hi everyone. Good morning. My name is Wenbin. I come from China. Currently, I work in Architecture Designing Institute and Research Institute at South China University of Technology. Now, I'm a visiting professor at University of Saskatchewan. My host professor is Huiqing. She is currently working in the Department of Mechanical Engineer. She is a famous expert on indoor and outdoor air quality control and contaminant prediction. I'm very glad to have this opportunity to give a brief self-introduction about my current research and collaboration at the University of Saskatchewan. I think my PowerPoint can be introduced by 4 points. Now, the first point is research interest. Now, I work in Architecture Designing and Research Institute, so my research interest can be generalized into following 4 points. The first is building performance simulation and analysis. Now, the second is designing, evaluation, and operation of green building. Now, the third one is HVAC system analysis and energy modeling in large-scale public building. Now, the fourth one is integration of green technologies in the renovation of traditional Lingnan buildings in South China. Here are some pictures about my current research. We use computational fluid dynamic software to simulate heat island and heat exhaust of air unit, and also air distributions in large gyms. Yeah. I want to give you an interesting example of the inspiration of ventilation in bamboo house, which is a typical traditional house in the Lingnan area in South China. That is, this building has 2 kinds of backyard, the front courtyard and the back courtyard. So these 2 backyard can absorb different solar radiation. So the inner surface of the wall is different, which can produce the temperature difference to introduce chill effect in ventilation. Now, the second part is my plan of research and collaboration at University of Saskatchewan. As we know, natural ventilation is an important shared topic for both green buildings and health buildings in China and Canada. And my host professor, Professor Huiqing, has great experience in indoor air contaminant prediction. So I want to work with her research team, and I plan to spend 1 year at University of Saskatchewan on assessment of natural ventilation and designing guidelines. I think the outcome will promote the utilization of natural resource in residential buildings, which can greatly reduce energy consumption for household and contribute to sustainability. Meanwhile, since I have dedicated my effort for building energy simulation for more than 10 years, so I will work with Professor Guo on energy modeling of greenhouse, plant factories, and food process industries to reduce energy consumption. I think my research work can at University of Saskatchewan can be divided into 2 parts. The first is natural ventilation. We want to utilize natural resource, reduce energy consumption, and also promote sustainability. And the second part is energy modeling of plant factories to improve green leaves produce or reduce energy consumption in such industries. I think my collaboration research in University of Saskatchewan helps advance the United Nations Sustainable Development Goals. I think it corresponds well to SGD 7 and SGD 11. Generally speaking, my research plan helps promote buildings and factories more sustainable. It can also reduce energy consumption in our daily life. Now, the third part is my detailed research plan. I think 4 points I want to focus on. The first is the influence of resident buildings layout to natural ventilation. Now, the second is the influence of natural ventilation to resident indoor environment and air quality in both Canada and China. The third one is assessment of energy saving of natural ventilation in resident buildings in South China and Saskatchewan. Now, the fourth one is energy modeling of plant factory, simulating the operation of the industry and predict energy consumption. Those 6 pictures describe the cross-ventilation simulation in resident buildings. As we can see, the more complex of the floor designing, the more airflow and the cross-ventilation will be introduced to analysis each apartment natural ventilation effect. I think it's a pity that the COVID-19 has become a worldwide pandemic, so this pandemic has negative effect on my research work. First, I had postponed my travel to Canada for about 5 months during the past 2020. The second, I have to work at home, which will reduce the opportunities for field study in the university. But I think it's fortunate that I can work online and make full use of internet resources to carry out my research work. I think with network video platform, I can work with my students in China and also my host professor, which can give me inspiring ideas. Now, the last I want to emphasize, in spite of negative effect of COVID-19, I think I still can have a wonderful time in Saskatchewan. Thank you all for support.
Hello, everyone. I'm Dr. Wang. I'm a visiting professor in the Department of Geological Sciences. And now I'm doing a research. This project is about how to build a global pathological database. And this can help us to learn our planet better. So this is my topic. To begin with, I will introduce my research and collaboration in the university. Then I will collaborate on my research interest. Lastly, I will give some ideas about how our work, our project will benefit the United Nations Sustainable Development Goals. First part, my research and collaboration in the university. This is Dr. Bruce Agliente. He is a picture and department header. And now he is active in the International Geopathological Database building. So today he is a working group leader in DDE. And he is a interdisciplinary expert, and he knows a lot about the geological science. He has done a lot on geochemistry, geochronology, and database building and data analyzing. I'm a senior engineer from China Geological Survey. I came here in February 2020. After I arrived here, I have a 2-week-long home quarantine. Then I have a 2-week on-campus visit and exchange. After the university closed, I work from home by Webex with Bruce Agliente. Our co-work area is pathological database building and sharing. Also, the work is a part of the IUGS Big Science Program, DDE, Deep Time Digital Earth Program. Usually, we have meeting online twice a week or once a week. I think it's a difficult time, but I also think it's a good time with living skies, and I see some beautiful sunset, sunrise. I visited some national parks, history sites, and I felt the enthusiasm from the people in Saskatchewan and Saskatchewan. Bruce Eglington has helped me a lot. I appreciate his help. I take some pictures in different seasons at the Nobel Plaza. I know there are many historic site buildings on our campus. Also, there are some famous scientists and people who had worked and studied here. And they won wider recognition. Today, in the past, they are doing what the world needed, and they win the wider recognition. Today, they are still working hard for what our world needs. Second part, my research interest. This is our beautiful Earth, and it's a planet made of rocks. Rocks are important for mineral resource, oil, gas, environment. The geological movements are closely related to climate. I think this winter is a warm winter, and the weather warms up. The glacier is getting smaller and smaller. We can see the glacier shrinking marks on the Rocky Mountain. Also, the marine fossils can be found on the Rocky Mountain. It means in the past, maybe hundreds of millions of years ago, the mountain is under the sea level. So the rocks are the memory of our planet. Today, we can use the advanced equipment to analyze the rocks, and we can get the chemical materials from the rocks. This information and data is very helpful for our human beings to find the gold mineral deposit and copper mineral deposit. This picture shows the past and the present of our planet. We know a lot of our planet present, and we know a lot from our research, pathological research. But what's the future? the rock edges can be analyzed from the rocks, and the polar geography can be analyzed from the rocks. Use this data. Based on this information, geologists can simulate the evolution of our planet and make a prediction of our planet for our future. Today, we have designed the geological database structure for the global geological database, and the geochronology and technology data can be stored in it. It's the foundation for rock analyzing. Professor Bruce Eglington has developed several databases that can be accessed from the university's website. The DataView database is for the geochronology, and it can be accessed freely online. Third part, I think our work will support the UN Sustainable Development Goals. I think there are 5 benefits. Firstly, I think our work will make a worldwide free access to the global geological data for everyone, for every geologist and every geological student. Also, it will allow a worldwide donation of the new geological dataset. I think these 2 benefits can reduce the inequality for people from different countries. Also, our work will enhance the international cooperation on access to geological science and technology. Also, enhance the data, knowledge, and technology sharing at IUGS and DDE level. Lastly, I think our work will embrace a lot of geologists to work together to monitor the evolution of our planet and create a beautiful Earth for next generations. I think this is also promote the partnership for the UN SDGs. Be what the world leads. This is the motto of our university, and I wish the university a greater success in the future. I wish everyone have a better year in 2021. Thank you, the International Office, offer me the chance to speak here. Thank you, everyone.
Hello everyone, in this talk I will introduce my research and my collaboration with researchers in University of Saskatchewan. My research is focused on developing methodology and software for big data problems. My major focus is in the area of genomics. I apply my research to solve real-world problems in various areas, such as the healthcare and medical research, agriculture and aquaculture, finance and engineering. The health and medical science is related to the sustainable development goal number 3. Here are my collaborations with researchers in University of Saskatchewan. I'm a visiting professor. My major home is in Department of Mathematics and Statistics, hosted by Alter. And I also collaborate with 3 statistics faculty members in this department. I'm also an associate member in the Respiratory Research Center. Joined a team led by Josh. We submitted a CIHR research grant recently. I will discuss this project in next slide. I also collaborate with Global Institute for Food Security. I joined another team which is led by Andrew. We submitted a research grant to UNSERC New Frontier. With computer scientists, I also collaborate. With computer science here with Tony. These are the projects. We work on. With the RC, our project is the investigation of relationship between childhood asthma and mental health outcomes. With GIFs, what we try to do is we try to find the link between 3D genomic structure and complex agronomic trait. We try to use this link to improve the crop production. With computer science, we are doing similar project with the GIFs one. We are also try to discover the link between other genomic features with complex agronomic traits. With the mathematics and statistics, our focus is methodology development for various other projects. Here are some other projects led by myself, or co-led by myself. The first project is funded by my UNSERC Discovery Grant. In this project, we try to develop a method and software to analyze various types of genomic data. This is the major project that I collaborate with statisticians here. The second project is Clean Plant project. In this project, we try to develop a diagnostic test based on the next generation sequencing. Our goal is using this test, we can quickly and precisely detect if a plant is infected by virus. The third project is about immunotherapy for COPD. We try to characterize distinguished population of immune cells in human lung. This research is done in single cell level. With this resolution, we can find much more novel information that we never found in the past. In this project, we try to identify what are subtypes of immune cells in our human lung and what are their proportion. Most importantly, how does this information change between COPD patient and health control? Such information change can be used as an important biomarker, a novel biomarker. This biomarker could be useful for drug development or diagnostic test. The last project I want to discuss is about developing a patient-specific surgery decision assistant tool. This is a simulation-based assistant tool. For each patient, each specific patient, we try to develop a personalized decision rule. There are many different parameters in the surgery. We try to use different parameters for different patients so that we can improve the outcome of reverse soldier replacement. That's all about my research. Thank you.
Thank you to our visiting professors. While some of them may not be here with us in Saskatoon, we hope that we will see them on campus in the near future.